Yeah, I think we can start. So good afternoon, everyone. Welcome to the today's invited talk. So our invited speaker is Ian Thurlow from BT. So he will be talk to you about the project they have been working and some of his personal experience and some of the opportunities that the students might could get benefited from. Ian, floor is yours.
Okay, thanks very much, Charith, and good afternoon, everybody. Okay, yeah, we'll talk about BT's data exchange today. So I'll talk a little bit about, first of all, about BT applied research and sort of my journey here today. Then I'll discuss things about the Internet of Things markets and the value of data. And they'll come on to one of our sort of BT's main products, actually, BT's Data Exchange, which is an Internet of Things data hub where we use to accumulate data from all different sorts of sensors. And I'll show how that's being used in a number of recent smart cities projects. There's one at Milton Keynes, one up in Manchester on the City Verve project. But the actual project I'm mainly working on is the Smarter Suffolk project with the Suffolk County Council. So I'll go into a little bit more detail about each of those projects as we work through. And then finally, I'll just finish off a little bit of new project work that we've just started, really, which is on remote patient monitoring in the health sector. So yeah, that's the sort of content of the little talk today. Okay, so first of all, just a little bit about BT applied research. Well, I mean, this place, which we've been based here at Adastral Park, you can see this at the top right-hand side here. This is our facility at Adastral Park in Suffolk. But BT has been, throughout its history and the companies before that, as part of the General Post Office and right back to the Electric Telegraph Company. There's a whole sort of raft of different innovations over a long period of time. So they go right back to the set of Electric Telegraph Company in 1846. I think it was a guy called William Cook and John Ricardo. Right through to some work on the first programmable computer, that was Colossus, which was undertaken by a post office engineer by the name of Toby Flowers. And that computer, which was mainly sort of based on valve-driven devices, helped sort of the decipher the German Lorenz cipher messages during the war period. So yeah, there's a lot of innovation going on at Bletchley Park at that particular time, and it goes all the way through to 1968, the development of the first digital telephone exchange based on pulse field modulation, right up to the present day, where we start to look at quantum key sort of distribution and sort of security mechanisms. So there's a whole raft of different innovations, that have happened really either at the BT or before BT as part of the General Post Office. And some of the sort of facilities we've got here at Adastral Park, because they've got the quantum and photonics labs. We've got a 5G test bed to look at new sort of 5G and beyond 5G technologies. A number of acoustic sort of chambers. We've got some huge network testing facilities as well at Adastral Park, and we started to build links as well with different universities, and one of those is the University of Suffolk, who've got a building here on site. We've just opened a new sort of robotics development lab, and have access also to the former Bentwaters site nearby for doing some sort of drone testing work. So there's a whole bunch of research facilities here at Adastral Park. We also do work with OpenReach, to sort of work on how to find new ways of getting the cables deployed into the ground, that type of thing. And we've got a new home that's just been built here on site in association with the University of Suffolk. So that's going to be a Digitech smart home, which again will be packed out with sensor technology in the coming months. So a number of different sort of facilities here at the Adastral Park. But we've also got a number of different research establishments around the world. So we also work with, we've got BT MIT out in Boston, in Abu Dhabi, we've got EBTIC, we've got some research centres in Bangalore, Beijing, as well. So we sort of do a fair bit of work with those institutions as well, those parts of BT. So yeah, it's a sort of global company. We look at both as part of applied research. We look at both the sort of the near and the longer term. So it's a couple of examples there. We look at immersive content. How to improve the viewing experience of the BT Sport. Like things like football matches, that sort of thing, other types of sporting events. We're looking at how machine learning and AI can be applied, and used in BT. Again, looking at quantum key distribution, and and as well as things like the research into different types of the different elements of the 5G network. But what we're talking about today is a little bit is our work on the Internet of Things, how we're trying to provide actionable insight from sensors and other connected devices, and how that can help sort of various companies in that sectors, across manufacturing, healthcare, and transport. So yeah, we've got a whole bunch of different sort of research teams running across the company. As part of this, we've got quite a good record. I mean, typically, we each year, we produce about 80+ peer-reviewed publications. There's a massive different patents in our portfolio now, over 5,000. Typically, we file 100 or so new inventions every year, and we have a number of relationships with the sort of different universities, University of Cambridge, Birmingham, Lancaster, Glasgow, and now we're building sort of new relationships like the University of Suffolk. So yeah, it's quite a lot of investment going on to the sort of research and development within BT. Okay, and we also have a number of different programs. So we're trying to get the sort of school children involved in different projects from primary school level through secondary school, and in fact, really eventually onto a university where we can then offer internships and and work placements. So we're trying to sort of get all the different schools involved in various projects and initiatives. My journey here, I'll very briefly on this. I joined BT back in 1978 as apprentice, so I did the usual typical things: how to install telephones, how to joint cables, how to fix telephone exchanges when they go wrong. And then for a number of years, from 1982 to 1999, I worked as a technician on the sort of call and transmission network. Again, really essentially fixing problems when they occur. But then I had a bit of a change back in 1989. Was sponsored by BT to do a degree electronics engineering, and that really from that point opened up a whole new load of opportunities, to be honest. So then I worked on a whole bunch of stuff from network management systems back in 1992 through the development of unified messaging platforms, and then quite a lot of work on knowledge management, like search engine and search agent technology, and that was the core to a couple of different European collaborative research projects, which were really interesting. So involved some travel. So yeah, very, very, very enjoyable time within BT. And then there was a little bit of work in a Bright Star, which was where we were trying to set up incubator companies to actually downstream the technology outside of BT. So that's quite an interesting experience working on sales support for that. I had a little bit of time in OpenReach on trying to forecast the demand for repair. So you're trying to predict how many engineers are required with certain skill sets across different parts of the country when bad weather conditions hit. And more recently, over the last few years, I've been working in the Internet of Things research group, where the main focus has been on BT's data exchange, which is really what the remainder of this talk will be about. And on the way, I've fortunate enough to do a bit more studying with UCL and sort of picked up an MSc and NGD degrees during that time. Okay, so we've now gone to the core part of the talk, really, which is really on the Internet of Things and data exchange. So, as we all know, the Internet of Things, it just refers to this ever-growing network of different physical objects that are connected via the internet, and the sort of communications that occurs between those devices, and bringing all that data into, maybe centralized systems so we can do some sort of data analysis on top of that data, learn new things, discover new things. So, there's a whole bunch of different market sectors out there, and I've just highlighted some of these ones that BT have been involved in directly through the use of data exchange. So certainly a key focus has been on smart cities projects, incorporating smart buildings, smart transport. I've done a little bit of work with sort of smart healthcare, so that's where the remote patient monitoring application will start to come in. I have other colleagues who have been working on sort of smart water applications with different water authorities. Did a little bit of work on the connected car with some telematics back from road haulage vehicles. And this healthcare area, I think, is going to be a lot of real sort of interest and work for BT in this area in the coming years, both in assisted living, so we're trying to encourage people to live in their homes longer, to wellness and well-being tracking, and also the industrial IoT. I mean, that's going to be a huge area as well, where we can look at, we're trying to track assets and stuff. So yeah, there's a whole bunch of different markets out there which BT have been involved with. And obviously that gives us a huge wide range of opportunities, anything from smart street lighting, where the councils are trying to reduce the cost of lighting the counties, to environmental monitoring, where we're sort of monitoring air pollution, air quality, down to things like optimizing the routes that refuse vehicles might take to empty the sort of municipal waste bins. So again, there's a lot of applications here: smart parking, smart signage, even down to how we can effectively use drones, maybe for delivery, that type of thing. So a whole range of opportunities there. I think it's really sort of come on really into the value of data. I mean, if you sort of maybe look at sort of a government report, HM Treasury report published back in 2018, they're telling us that that the data-driven technology is worth just a huge amount of money to the UK economy. And one of the key aims is trying to boost productivity. And that's really to try and gain insight into things that work well and what does not, which really comes into my work with the Suffolk County Council and how they could best make use of data to improve local authority highway services. How can you more efficiently grit the roads during the winter time? How you can more efficiently get the drains cleansed, the road drainage gullies cleansed, throughout the year. And I think a lot of information can be gained from trying to piece together all this data, all this information from multiple data sources. But the problem with that is that often the data sits in lots of different silos, lots of different databases, and it's how to try and get access to that data quickly and to actually use that data. Because it's a very costly and sort of time-consuming process to actually trying to sort of interface to multiple systems, to pull the data, and that's really where BT's data exchange came along. Really, we saw the opportunity that we could perhaps accelerate the way that application developers at least and customers can get access to these data sets. So that's what I'll come on to, is actually BT's data exchange data hub and how that's then used to do a lot of the integration work. So I think I've got two parts of the slide here. If you like, this is the without data exchange. So on the left-hand side, you've got a whole bunch of data producers. You've got sensors. You've got systems that are collecting data from sensors. They could be road traffic. They could be transportation. It could be weather data, both observed weather and forecasted weather. We could have data that comes back from CCTV cameras, from the street lighting. And what often happens without data exchange is the data consumers, they're then developing like siloed applications for either transport or lighting. And it's quite difficult. Often you'll find out that to actually gain access to all these different systems is very, very time consuming indeed. So BT's data exchange comes in here really, whereby BT takes a lot of that hassle away. So we provide a data exchange, Internet of Things data hub, where effectively do all that integration activity on behalf of the application developers or the end customers. So we do all the onboarding of data from all the different data sets, whether it's traffic light, transportation, whatever, and we bring all this data into data exchange. And then what we offer to the data consumers is a consistent application programming interface. So it's a uniform interface, so they access the data in the same way, irrespective of whether you're putting back road traffic data, transportation data, weather data. The mechanism to retrieve that data is very, very similar. So we provide this sort of catalogued data hub where application developers can then search the catalogue, find data sources of interest to them, explore those catalogues, and then essentially through the API retrieve that information. Now, within data exchange, we also have ways of sort of monetizing that data. We didn't do it from the particular project I worked on, so there wasn't a charging mechanism in place. It was more a proof of concept to prove that BT could, in fact, integrate multiple data sources into one platform and then give a uniform access to that platform. So that's essentially what data exchange is trying to achieve, is trying to take that headache away from integrating multiple data sources. A couple of example projects that BT have worked on one down in Milton Keynes. Again, this was just showing how you could integrate air quality data with data about the car parking space availability, along with live timetables from the rail network, the bus network, and also coupling that in with data taken from traffic counts. We've got some sort of camera and radar sort of technology really, which then try doing sort of counts of traffic, so you find out how busy different sectors of the city are, and all that data was brought back into data exchange along with the weather data, and from that they developed a city motion map application. Again, not surprising, it gives parking availability, allows you to visualize what the current status of the public transport is, where the hot spots are for pedestrian activity, to bring that all back into one application. Now, this application itself was developed by a third party, not by BT itself, but it's using that API into BT's data hub. So that was one particular smart city project that we worked on. Another one was City Verve up in Manchester. similar type of thing really, where we're trying to look at air quality, the quality of air, the quality of the air across the city, and also looking at the transport infrastructure. Looking at weather observations. But the neat thing there is we teamed up with a company called C-Sense, who provided a number of sensors which could then be fixed onto the onto cycles, and that enabled us to sort of track really where the routes the cyclists were taking through the city of Manchester, try and find the hot spots. And they also added some technology to their sensor, which you could sort of gauge, if you like, the roughness index of the road, based on sort of the vibrations picked up by the sensor, and you could then classify those road surfaces and routes through the city as different types, whether it's smooth, rough, that type of thing. So I think that thing also gave the city council insights into, the route cyclists were taking and sort of the dwell times at various sort of like junctions, that type of thing. So give them sort of more insight into the data. So that was CityVerve. And then the potential project I worked on was with Suffolk County Council and Suffolk Highways. And what this was all about is trying to utilise the street lighting columns around the county to sort of deploy sensors on a mass scale. And really with the aim of improving the local highway services. Obviously, the aim there is for Suffolk County Council to try and reduce their operational costs, but also to look at new services that could be enabled by, through the sensor data. Now, within this project, BT had really three main roles. The first was then to use this data exchange, as I've shown, to aggregate all the data from all the different data sources together and to expose that data through a single interface. We also provided some quite basic time series visualizations of the data sets. So again, so we could quickly give the developers and the Suffolk County Council a view of that data. And also to use a Astral Park here as an evaluation facility. That gave us an opportunity, like with the sensors that were measuring road surface temperature, to basically mount a whole bunch of these sensors onto a lighting column here at Astral Park, point them down at the same tarmac area, and then working with the University of Suffolk, then compare the data from the different sensors from the different manufacturers. And that work was then used to inform Suffolk County Council, about the the quality of those sensors. Did they do what they were supposed to, that type of thing, in order for Suffolk County Council to make purchasing decisions in future. So yeah, BT aggregated the data, provide the dashboards, and also enabled us to use the Astral Park here as a test evaluation facility. So that's just an overview of the project. It all started off really with a little bit of work that we did with Suffolk County Council on a piece of road here in Suffolk on the A143, and that was again to mount some sensors onto traffic light columns to again dim the lighting according to the traffic patterns at night. So traffic patterns coming at night, we could dim the the lighting accordingly during the hours of darkness. So that's what started off, and that then led to the Smart Suffolk project. So here we see on the left-hand side, we've got different local services. We've got lighting, winter gritting, gully cleansing, and there's significant costs associated with each of these. Obviously, the roads, you get snowfall that causes significant disruption, in some of the winter months, as can if the drainage gullies get blocked, it causes localized flooding that disrupts the traffic, that impacts on the economy. So there's lots of ways that Suffolk County Council can look to adapt these services, use data to improve these services. So mounting all different types of sensor, either on street lighting columns or in the drainage gullies, bring that data back to a data exchange, or accumulating it in one place and giving access to that data, providing some simple visualizations. There's a couple of examples here of, on the left-hand side, this is the road surface temperature, and on the right side here, we're doing traffic counts. Look at the average speed at certain junctions and the actual count of traffic, and bringing all that back, to enable Suffolk County Council to sort of visualize and use that information. There's some of the data sources that we looked at. So we're looking at measuring relative humidity, road surface temperature, wind speed. You can see them all down here on the left-hand side. Levels of silt, water in the drainage gullies, different types of traffic count, and also the classification of that traffic. So not just that there's a vehicle there, but what type of vehicle. Is it a taxi? Is it a car? Is it a bus, lorry, that type of thing? and also did some work with some grip bin sensors. We've got a number of grip bins dotted around the county. Again, it's just putting sensors in those to measure the levels, so they could be more do the refilling in a more sort of slightly more intelligent way, and it's similar with the waste bin levels in the municipal waste bins. So again, it's bringing all that data back into Data Exchange to enable better winter route gritting, route planning, better traffic management, and also to measure the air quality across different parts, in Ipswich, Bury St Edmunds, Lowestoft, different parts of the county. So there's some of the applications that we used, the data was being used for. From a developer's perspective, to get data into Data Exchange, you get in a number of routes really. A lot of the work is for BT to write these edge adapters. That's the bit that interfaces to like a supplier's platform. So you could have a supplier providing a bunch of road surface temperature sensors, and they bring all that data back to their own data store. Then they publish an API onto that data store. So a lot of work goes into writing these edge adapters to interrogate the external API, bring that data back, and import that into Data Exchange. Other ways of doing it, we worked with a small startup company out of the University of East Anglia, and their preference was for us to set up the data feeds, but for them to post their own data from their data store. So we didn't actually, in this case, write the adapter. And it's another example here, we were actually linking into a LoRaWAN network server, again, which was then posting data to an edge adapter, which in turn posted that data into Data Exchange. So a lot of the work from BT's point of view is to actually write these adapters, and if you like, take the headache of trying to, for developers having interfaces to lots and lots of different data sets via lots of different APIs. We sort of try to take that headache away from people. Okay, as a retrieving the data, well, again, we provide a searchable catalog of data, and typically a user would then search the data feeds and then subscribe the ones that are of interest. And then that data feed is a description of it, what the sensor is, what it's measuring, where it's located, what its lat long coordinates are. They can then query that data through a common interface and retrieve that data. And then we provide also a few visualizations of data sets as well. So again, yes, a lot of the work is then just getting used. Once you've got used to the Data Exchange API, you've developed one set of sensors, then it's a very, the same API, and you retrieve data irrespective of what the sensor is in a similar way. So it should take a lot of that sort of effort away from people. They can just concentrate on the actual data and the analysis of data rather than doing the integration. Here's a couple of examples of an example dashboard. Top left-hand side here, it's just looking at a traffic count and average traffic speed. It's looking at the typical, you see the typical traffic profile as it builds up in the morning, sort of flattens out, and then sort of almost a peak in the evening, and then it obviously tails away in the evening and to the early hours of the morning. And that data was, I think that was collected through like radar type sensor technology. Below here, we were actually using, or not BT, but one of the external suppliers was using a camera technology and then classification based on the images. So again, you could then split that traffic count into different types of vehicle or pedestrians, so cars, taxis, vans, minibuses, emergency vehicles. So it's trying to detect the type of vehicle, not just the count of, or a total count of vehicles. And up here is the same data, just visualized in a slightly different way. So in this case, we're plotting vehicle speed against, or traffic count against vehicle speed. And you can see there are instances where, obviously here, there's a couple of instances where the speed limits have been broken. And around here, again, we've got with some sort of congestion occurring, but there's a lot of vehicles traveling at a much lower speed across that particular junction. And in the bottom, excuse me, bottom right-hand corner here, just looking at road surface temperature data from a small startup company, which beginnings of the UEA. So again, that's just monitoring this road surface temperature. So that's some simple dashboards that we provided. Now, clearly, there's going to be some issues with some of this sensor data. I mean, this example here on the left-hand side, the mechanism that was used to retrieve the data in this case was to do a secure file transfer protocol connection from the Data Exchange edge adapter to the supplier's platform, and then every 15 minutes to download a file, unpack the contents of that file, and post the contents of that of that data extraction into data exchange. There's a number of examples where there's actually missing data. So clearly there's a couple of good examples here where just that file for some reason or other wasn't on the supplier's platform, so you get missing data. You also get a few examples of anomalies. This example is the road surface temperature. You see I've just highlighted an anomaly here, and clearly that's not valid data. And similarly with the the grip bin levels, you can see some variation here. Clearly this is the grip bin is pretty full, and these are errors in these examples. So what it is, one of my colleagues then sort of working on anomaly detection algorithms to look at these data streams and then to identify where in the data streams we think that an error or not a set of anomalies have occurred, and to mark those accordingly. That way a developer can look at both the the raw data stream and the other data stream, which we then say is, we think we've got the times where an anomaly has been detected, and they can then choose to ignore that data if they wish. So we certainly get anomalies within as the data passes from one system to another, and I think there's a good example of this on the right hand side, where the sensor data was brought back from various sensors via a network into one supplier's platform. That supplier provided an API to their platform to retrieve the data. A second supplier retrieved that data and made it available via their API, and then we connected to this supplier's API. And through chance, just a little bit of work with the University of Suffolk, who were doing a direct data export from this system. They had access to this system, we didn't, and was comparing with some data I had in data exchange. There was some anomalies detected here, so that I think it was on this particular platform here. So just so we should be mindful of which systems we connect to, what the path is that data through those different systems, and to understand that that anomalies do occur, and we have to be sort of mindful of this. So again, it instigates some research on how we can try to guarantee the authenticity of that data from the sensor through to data exchange. Okay, Smarter Suffolk. So the key outcomes, I think, in learning from the project, that we did use data exchange to accumulate sensors from a huge range of different sensors, and we brought together some data sets that had not previously been brought together. We enabled that to all be queried and visualized in one place. That data exchange was also used to support, as now actually a couple of hackathon events with the University of Suffolk, where students use data exchange to explore the data sets and come up with some novel ways of using the data in some new applications. And just a little bit of feedback we got from Suffolk County Council while running one of these hackathons. To them, having the data all in one place is really a game changer for them. People do not have to log into multiple systems, have to understand multiple systems. They just go to one place and retrieve the data. And another employee of Suffolk County Council again found it very easy. You can see how the students could quickly pick this up and interact with the data. So yeah, very straightforward to use. I think future data exchange, we are now downstreaming a data exchange from applied research into the wider BT. So BT will now deploy data exchange as part of a sort of managed service offering. But I think if we were to run future sort of projects like this, the key things are to get the sensors and get access to the sensors at the earliest possible opportunity, because this does take a little while to write some of the adapters. And also to engage the end user end base a little bit more to get a better feel for how Suffolk County Council will eventually use this data. Again, I think that was possibly missing from the Smarter Suffolk project. So I think that's working on something similar is really key to get the the end users more involved. So that was the Smarter Suffolk project. So that's now come to an end. We're now sort of downstreaming that data exchange into the wider BT. And myself, I'm now working on sort of another thing we're now looking at, which is next generation sensing, which is going to a little bit of a focus on remote patient monitoring, sort of for healthcare applications. So if we look, general background to this is, the sensors are getting smaller, they're getting cheaper, they're going to be utilized across all different industry sectors. There's a couple of examples on here, from the smart home to the industrial IoT, in smart agri-tech, transportation, logistics, gaming, energy. And one of the areas I'll be looking at is, is how we can use like IoT in healthcare. Essentially, what we want to really look at is, how new wearable and sort of sensing technologies plus sensors that can be located in the home can be used to sort of bring this data all back together. and basically, give updates on the general sort of health of a particular patient. So that's what we'll be looking at in the near future. I mean, part of this is BT's ambition to become, I think it's on our mission statement, to become the most trusted connector of people, devices and machines. And we see healthcare as as a leading sort of vertical, an area that we're making a lot of use of sensor technology, either in the hospital, medical centres, ambulances, or indeed in in the home. So we've got lots of opportunities here, I think, to sort of research. Wireless body area networks, where we connect these different devices around people, even ingestible devices. Connect that with the ambient sensing technology, so you're trying to monitor the temperature, air quality, humidity in the home stay, bringing all this data back to either edge or fog or cloud computing, and then find ways to actually then identify like anomalies in those data streams. Could you monitor and pick up anomalies in the patient's vital sign data, that type of thing. And eventually, not today, but over the coming sort of months, the project is going to work towards how we actually represent all this information through digital twins and avatars, and have some sort of metaverse virtual representation, a virtual world whereby anomalies picked up in a healthcare worker accessing one of these sort of virtual worlds will get alerted to anomalies picked up in a patient's vital sign. Will then be able to actually look at that virtual and then see what the activity of that patient was at the time that the anomalies were detected. Were they asleep? Were they busy? Were they quite active at the time? So again, it's trying to give additional information back to the healthcare worker of what that patient was doing at the time the anomaly was detected in the healthcare data. So that's a sort of project that we've just started off, and we'll be sort of looking at for next financial year from April onwards. Okay, so as part of this, there's a whole different bunch of sensors out there. Whether you're measuring temperature, humidity, using ultrasonic sensors to measure a whole bunch of different sort of things. Are we measuring ECGs? Are we measuring rapid eye movement? Not brainwave analysis quite yet. Blood pressure measurement. And also doing things like fall detection and voice detection, those type of things. There's a whole bunch of topics that we're going to be picking up in the coming months. Okay, well, that's sort of like a whistle-stop tour really through sort of some of the work at BT Applied Research, how we've used data exchange on a number of smart cities projects, and a little insight in which we're going to go into in future with them sort of in the healthcare domain. So closing points, we've got this ambition to be a world's most trusted connector of people, devices and machines. We've used data exchange in a whole bunch of smart cities projects. We've downstreamed it into BT Enterprise, and we're now aiming to become a key player in the healthcare sector. So we're going to be working on things like remote patient monitoring and assisted living. So that's how we've used data exchange. Obviously, BT, we run a graduate scheme every year. So if if you're sort of interested, please take a look at the BT graduate scheme website, and all the information is on there. So thank you very much.